Hello, I'm Veer.
I'm Preetham.
We are presenting our project titled Smart Environmental and Safety Monitoring System.
So this detects a lot of qualities in the environment. So basically, we are starting off with air quality, flammable gas quality, temperature and humidity.
Pressure, altitude, and also flame in real time.
Indoor environments often face issues like poor air quality, and due to the rooms being very small and compact, we face high humidity also in the rooms, and there may be small gas leaks or even problems like fire risk, which may go unnoticed sometimes.
Without proper monitoring, these can lead to health issues and safety hazards. So our project provides a compact and a real-time solution to monitor these conditions.
Yeah, so coming right now to the objectives. The major objectives of our project are to start off with to detect the air quality and different gas levels,
And monitor the temperature, humidity, and pressure.
and then we detect harmful gases, flammable gases, and even fire.
And display all the reading in real time on an LCD.
So right now coming to the components overview, we have the Arduino over here. This is the main control processing unit. And next up we have an MQ135. This is a air quality detection sensor. After that we have an MQ2 which detects gas and smoke, or basically flammable gases. And next to it here we have the DHT11 sensor that detects humidity and pressure in the environment.
This is an LCD which displays all the value detected by the sensors. And coming on to BMP280, it is a sensor which detects temperature, altitude, and pressure. And here is the flame sensor which detects the flame, and if the flame is above a certain level, then it is connected to the buzzer. So the buzzer turns on if the flame is above a certain level.
So coming into the circuit in detail right now, we have Arduino as our main controlling unit, and the power supply from Arduino is the 5 volt, which is connected to the breadboards, and we have put two 5 volt rails and two grounds to simplify our circuit. To start off with the sensors, we have the first sensor, that is MQ135 over here. This MQ135 is connected to a similar common power rail and a similar ground on the breadboard, and this goes to the A0 analog input of the Arduino. And the MQ2 sensor over here, which detects the smoke and the flammable gases, this goes to the A1 analog input in the Arduino, and it has similar 5 volt power rail and the ground. Alright, so I've mentioned before, on the breadboard, this red line over here would be the 5 volt line, and right adjacent next to it would be our ground. And similarly, on the other hand, we have connected with our normal wires. We have the similarly 5 volt line and the ground line over there. And the next sensor we have up would be the DHT11 sensor. This goes to D2 of Arduino. This is where it goes, and this sensor measures temperature and humidity, and it has similar 5 volt. It's connected to similar 5 volt and the common grounds. The next sensor we have is pretty interesting. This is the BMP280. This tiny sensor over here. This measures the pressure, the temperature, and even the altitude out there in the environment. It has actually 6 inputs with a VCC, ground, SDA SCL is what we are using at this particular moment. The SDA SCL are connected to the A4 and A5 of the Arduino, similar to the ones we connect to the I2C chip of LCD with. But this thing is not just connected directly to the 5 volt line. This is connected to the 3.3 voltage line of the Arduino. So we have to be careful with this one. Coming up next is the flame sensor. As I've mentioned before, this comes in the safety part. This detects fires in the rooms and environments out there. So this is similarly connected to the 5 volt line and the common ground yet again. And this particular D0 of this flame sensor connects to the D7 of Arduino, which outputs the data, digital data. So the next add-on to this safety detection would be the buzzer. So if the flame sensor, as mentioned before, has some certain values which are exceeding the particular limit, the buzzer warns us with by its turning on. So the next component of our project would be the LCD display with the I2C module in it. So this outputs all the values of the sensors over here. So as I can show you over here, so the temperature and humidity by the DHT11 is mentioned, and this comes with a 2 second of delay. The gas that is of the MQ2 sensor, this is the pressure and altitude of the BMP280, and if there's any flame, that would go into yes. And the air quality index 18, it outputs good and clean as of now. Initially, we had only two components in our particular project, the MQ135 sensor and the DHT11 sensor. Later on, we added three more components and sensors to increase the safety measures and the safety features of this particular monitoring system, and increase features which we can measure of the outside environment. And after integrating the circuit with the Arduino, using a lighter to light up the flame sensor and the inflammable gas sensor, we can see the buzzer has gone off. And as we can see in that particular section of that, we might be able to see the flame comes out to be yes for that particular moment. This is what happens when we use the flame sensor, and this is how the safety system of this particular mechanism works.
It can be used in hostels, homes, classroom to track air quality and humidity to maintain a comfortable environment. In industries and laboratories, it can detect gas leaks and fire hazards, thus improving safety. Also, it can be used to detect altitude and pressure at different geographical locations. In conclusion, we have developed a compact and a cost-effective environmental monitoring system using multiple sensors integrated with an Arduino. This project demonstrates how sensor integration and microcontrollers can be used to build practical and scalable safety solutions. Thank you.